Ja, wat een nonsense. Past an array here, it just starts at index 0 every time. So we want to get the last one. I need to fix my mouse. What? Well, I could add that, but it should not be necessary, and currently it doesn't work. Which is why I assert. The assert is just added to make sure that we don't try that. This is the end. So it doesn't work in the previous one. Or we have to move children. Well, no, this is black to move children, so white just moved. No, that doesn't make any sense. I think I just added to the wrong thing then. I think it, or, well, no, never mind. Let's see. Yeah. This one is before we print it, immediately after setting to move. Yeah, here we have a case where the white king blocks a check if the rook moves here. So this parent position is not generated. Well, actually, I'm seeing it. It's right there. What the hell? No, it's not. It's something else. It's already blocked at the initial position. So this one work. It says original child position, blah, with 31 legal moves, and then generated and everything works out. So we go to the next child position. And the next. And this one fails, therefore I print what was generated. So this is the child position, and then black can of course move the king up. Or down. Moves it down here. And up. I'm confused. It's white, sorry. The black king just stays on row 4. The white king goes up. White king moves work. So that's why it just finds it. It can go up. It cannot go here with the white king. Can we? No, it cannot. Or go there, I mean, came from there. If the white king would have been here, then black would have been in check, and then with the white to move, we would just take the king. That is not happening. But the white king could have come from here, because now it's not an illegal position. And then we can reach the position where the white king is at row 7 by moving down. Looks like a bad move, but it's possible. Or the white king can move down. That's the only two king moves, yeah. And then of course we could reach this position from here by moving the white rook to the corner. I would think then the generated moves are correct. So then the generated legal moves are wrong again. Ah, right, it's not correct. You can also move the rook down. The rook could have been here and then moved to the top, or there, and so on. That's what we are missing. Which is related to blocking. So currently I'm saying if it is already on the same file as the black king, then it cannot have come from there. Because if the white king would not have been here, then the white rook could not have been here with white to move. But that one is there, so the white rook could have come from here, but not from here. Well, it would go through the white king, of course. So that means that if the white king is in between the black rook and the original or the target white rook position, as it is here, then we do need to generate all rook moves in that file, because and just simply until we hit the king. Now, where's my code? It's only one switch. What the hell? Istanbul.h. Yeah, here it is. Yeah. All those things are templates. Right, so generated rook moves. Here we are. For all directions, evaluation as parents. If the white rook x equals the black king x, so this must be extended to, and the white king is not in between. Then we do nothing. But if it is in between, we can just start moving the rook until we hit the white king in all directions. So, and not is between no column, in between. What? is between. But no color. Oh no, of course no color. I have to add something. Less or equal or less than. Oh, we have color. So the equals doesn't really matter because the y coordinate, I mean, if the x coordinate is the same, then the y coordinate is not also going to be the same. So don't have to worry about that. So the black king y, and then the white rook y, and the white rook, and the white king y. To test if the white king is in between the black king and the white rook. Doesn't matter where you put these two. The exact same test goes with south. And here we get the same thing, but with x. Already have in between. No, this one goes wrong. This says it has 14 legal moves. And I count, well, the rook could have come from here. That is 12, 13, 14, 15 or 16. That's 5 of them. Or down here. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yay. And I'm generating, well, that rook is high on here. So it's going to move down from 12 to 11, giving check. Or 13, or 14, or 15, or 16. And we're moving towards the king. Seriously. Why? Oh, God, the equals. That's funny. I'm just looking at the x coordinates. So the rook is equal to the x coordinate of the king. In this case, so it thinks that the king is in between these two. But it ain't, because... Wait a minute, that should not be true. I'm also testing the y coordinate, am I not? The y coordinate of the white king must be equal to... Probably not testing that. Let's have a look at the code again. Yeah, that's nonsense indeed. So if this is the case and not in between, it means that not only the y coordinate must be in between, but also the x coordinate must match. Which means the white king x coordinate equals the, well, one of these. And this is what we just saw. Or you must check that the y coordinate, white king y coordinate must be, of course, the same row as the black king. The original child position. Okay, 32 legal moves. Well, that is I guess 15 horizontal plus 15 verticals, 30 plus 3 is 33. Oh no, this one is ruled out, even though the king can take it. This is white to move. So yeah, there is 14 plus 15 plus 3 for the king. And the thing that we generate is a king move. Oh, a totally illegal position. This king could go to row 6 here, go down. Or the king is here and then go to a6, or the king is at b6, right? Yeah, and then it can go to a6. So those are the 3 king moves. And then we see the problem. It is generating, well, maybe it still comes, but I have the feeling that it's not generating this move. Thinking that black is in check then, but it isn't because the white king is in between. Yep, I'm only stopping vertical movements, or not stopping vertical movements. If the rook is already there, I'm still not taking into account that the white king blocks a check if we move perpendicular to it. Which is what I have been looking for all this time. Finally we reached the assert where that is showing itself. So the disposition is missing. But the rook, of course, goes all the way to the edge. And then we have also the vertical movement. It goes down first, and we should skip giving check. Yep, it goes from here, from 5 to 3, so not giving check. And it should also have gone up, which means 11, 12, 13, 14, 15. That came from 16. Okay, yeah. So the problem now is that I am skipping it. That would be this one. So at the moment we find out what the check step is, I could also find out if it really is check by doing an in-between check. And the check step is calculated here. So this was always the case, always calculated this. And if the white king is not at the same file as the black king, then we still always need to do that, because, well, check is definitely not going to be blocked. But if the white king is on the same file as the black king, then it could be necessary to skip this, because it could also not be checked, because the white king is going to be in between those two. And then, I mean, of course, the y coordinates, and well, the y coordinate of the black king and the white rook. Yeah, this is just the white king is in between the black king and the white rook. In a minute, so we're changing this. So it's there. Yeah, that it looks correct. Let's negate it. That's where it says that there. Is there any difference at all? Yeah, this is different. Between north and south, and or east and west. That's the same. This is different. Not a check though. Just that is different. No, this is also different. It's a plus or a minus. Yeah, to almost try to remove some code duplication here, but it's tiny little bit different. It's probably not worth it. And it wouldn't surprise me if it now works. Well, that means that now I have correct parent generation. Awesome. Tested 35,186 positions and all of them worked. And then again 3,000 with the other color to move. Yeah. And if Okay, this function is calling to generate neighbors with parents, which now finally works. Therefore, this piece should be generating all parents that are made in one ply. Let's print them. I think that the underlying block stuff is out of the picture. Make it complicate things, but I might as well make a smaller board, I think, because it takes up a lot of monitor space. For the testing, let's say, can I set this to 1 even? Nope. Yeah, an empty mask. If bits is 0, I don't see the problem really. It's easy enough to test. Just allow it and then see if it's over. Totally works. Actually, it doesn't. I turned off the test suite. Dang, it does not work. This seems so wrong. I mean, the only problem is that the rook is gone. Where is my rook? I mean, the rook can be under the king, but since the king is being moved, there's no rook here. There's no rook here. Let's print the whole board. As in, oh, the white rook is under the white king. How did that happen? So the zero legal moves is correct, because those are legal, and then I'm trying to find the parents of an illegal position, which is, yeah, doing undefined behavior basically. So no problem there. I think the problem is that the original position is illegal to begin with. So how do I get this? Oh, okay, I get it. Yeah, the reason is that I made my board smaller. So I made two changes. I made the board smaller and I removed the block. So no longer partitioning the board into blocks. But the actual reason is that the board is smaller. Therefore, the white king, which normally just moves around the black king, now reaches 0-0. And I also put a rook there. So we need an extra test, simply. So for this black king, I find white king positions, and then we continue if it's off the board. We can also continue if it's at the same place as the rook. Well, actually, we must have the rook coordinates before I can do that. So off the board, never try to generate moves after the white rook is already captured. And don't generate positions, I guess. If not, something is legal. Continue. Okay, legal must be called on info, well, on a classification. So classification must be called on info. And this info is stored in generating a white to move children. So these things have black to move. Yep. Thus black to move. Just my info, and we'll add the current board, which I didn't generate yet. The board here. And then I have to do that again. While generating the black to move children. And what is this doing? Exactly the same. What? Two fuel lines. Yes. Okay, so yeah, I'm totally happy with that. So I want to print all these boards. What else do we pause here? To move. Well, white. Oh, there are no made one-ply positions. Ugh. What takes a size type? How is a get value not returning a size type? Int. Vector index. This is the one that returns the size type. Oh, it's not taking this. Not taking and size type. I'm taking the info index directly here in this version. Okay, so those are all the mate positions, yes. And then we call to move set maximum apply on parents. On black to move info. Passing info index from which I can reconstruct the board, apparently. Which we do. Found one parent. Should be 7 parents. All these. Hello, EE. Yeah, how do we answer that, right? Entering info, black to move set maximum apply on parents. Black king is at 0, 0, white king is at 2, 0, and the white rook is at 0, 2. Number of parents. This should work. And this thing definitely has 7 possible. What the hell? Oh, why is it saying black? That should be white. And actually, if it is... what? It definitely should be white. I'm just thinking that if it pass black, find the number of positions that can lead to this position with black to move. Well, none. There is no way that black did the last move here. So that's why I think. And why does it find 1 number of parents? It did, didn't it? Next. Found 1 parent. What the hell, man? Generating king moves. That looks pretty uninitialized. No, I just didn't execute yet. Why is it going back and forward? Four, 2. Well, that's correct. Calculate the squares that are blocked by the enemy king. And that should work. It's 8 bits, right? 3 plus 3 plus 2. Yeah. So I suppose everything is intact and it should be surrounding the whole king, or no? That's nonsense. This is, we want to print this in binary. Can we print this in binary? Ah, I can't print it in binary. Hey, Abhimanyu, can you print binary in GDB? T is binary. I didn't know that. Awesome. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 3, 4, 7. So it moved it here, the square. I'm not sure that looks good. Thought the actual king was here. So that would only be stopped from going to 2 squares. I think west and east are swapped here. North is here. So it would be stopped to go east and northeast only. East and northeast. Ah! What? No. Yeah, well, okay. So it's still... No. I want to be blocked in this square too. But a step from off the edge, so it wouldn't even matter that much. Still a bit weird. I mean, it's really, it looks like the white king is here, which of course would also be the same thing. I don't know. Anyways, where am I? Well, maybe this is for moving. So west of king, what the hell, man? Oh, that's the rook. Something is wrong here, though. If I interpret the mask correctly, it's print from 400. List 400. Okay, let's print from 380. So the black king is here and the white king is here, right? So it should be blocking G, I, and K. That is here, G, I, and K. And the least significant bit is here. So we should get a mask with 16 0 bits. 8 and 8. And then 1, 2, 3, 4, 5 0 bits and then a 1. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm miscounting probably, because now I see only 4 here. One, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. There's only 4. But okay, definitely what I miscounted totally anyway. One, 2, 3, 4. Oh yeah, the program is right and I'm wrong. Okay, so this is the first one. That's correct, of course. What is being blocked is these. So you have a little square here and a 0 there. These 3 are set, so the king cannot go east, because east and west are flipped here. So the calculation of this is correct. And now I'm going to calculate the blockage for the white rook. These masks are used to mark squares attacked by the white rook relative to the king that is moving. Now we are in check even, so the white rook is somewhere here, so that should be attacking this square and this square. It was through the king. And then we should end up with 0 moves, because we cannot go here because of the enemy king. We cannot go here and here because of the rook. And we cannot go here, here or here because that's the edge of the board. Yet it finds 1 move. So what is going wrong? XY encoded delta. So the encoded means that it adds 2. So this is -1 and 1. What the hell is it, -1 and 1? Oh no, we're adding 1, sorry. So it is 0 and 2. Yep, that's correct. The x coordinate is the same and the y coordinate is it's 2 away from the king, I think. Yep. So white rook y is 2 larger than the y coordinate of the black king. So it must be rook minus king. And that's what it is, rook minus king. And then I get rook square. Calculate square, that is the white rook, that is the ruikmoed, that the white rook occupies. It's a single bit, okay, so that is where the rook itself is. Let's fix his comments. I'm so happy with the /t. I can finally print binary. The rook is not occupying anything. Well, it's in the neighborhood of the king, so it's too far away. That's what happens. It's just too far away. So we use this 0. Yep. Okay. Then relation is parent, right? Yeah. So if the relation is parent, then irrespective of who is to move, the king can't come from the square where the rook is. But yet it couldn't anyway, because the rook was too far away. So nothing is blocked here. This is set to 0. If to move is white, no, because it's black. It should have been white, but it's black at the moment. Oops, I skipped too far ahead. Five, 6, 4. Add the squares that are blocked by the rook. Rook blocked squares. Okay, I'm definitely missing something here. It's also a wrong comment. Yeah, bug. How the hell did my test suit not catch this? That is so disappointing. It's funny. So I'm subconsciously playing with anything in reach with my left hand, which is also next to the microphone. Then doing that for days, like with a 2x2 Rubik's Cube, continuously, or pliers. But just now I thought that must make a noise, and I keep doing it. So let's put those things far away. So I was playing with these pliers, so like doing this all the time, and I threw it to the other side of the table. And I'm thinking. Suddenly I realized that I have pliers in my hand. Yeah, different pliers. I had to make pictures of this. It's just funny. I literally two sets of pliers. One is red handles and the other has black handles, so for the rest they look the same. Okay, black handles also goes over there. Maybe I want to play with something, and I should use something that makes no noise. Like a piece of cloth, yeah. Do you hear this? Okay, I think I need a break. The main problem at the moment is that my test suit didn't catch this. So this is a situation where I think the black is to move, to generate parents, and the black king is in check, and then I want to find the parents. But that's illegal. Oh, it is not possible. Yeah, no, of course. The black cannot move itself into check, so it doesn't have to work. That's why the test suit didn't catch it. Okay, we analyze that. So yeah, then the problem was that black was used in the first place. So that is here. Black to move set maximum plier on parents. Okay, I never tested that yet. So this must be parents, so that is white here. Do I have a white to move function? Nope. Okay. Not yet. Or actually, that would be set minimum ply then. Also, don't have that. No, I don't trust it. Info. No, I don't have that yet. Now this position again, and now we have found 7 parents. Yay, there's the 7 of the possible hooks. And the first one is totally wrong. Oh no, wait a minute. That is testing it, and then we go to the next one. 7 is again D7. Yeah. But I wanted to print the parents. Why am I not printing the parents? I'm now printing all the positions that are made still. Oh yeah, why don't I print this? One ply, why to move parents? Is that not happening? Yep, it's still empty. Made in one ply positions. Nothing. Well, I found 7 parents here, and 7 here, and 7 there, and 7 everywhere, so this should be a lot. Yeah, I don't know, man. It depends on what your purpose is, right? I mean, Python is a beautiful language. I don't think it's. I don't know it. I never learned it. But I feel like you just need to know Python at some point, probably. Although, like I said, I never learned it. But to become a full-fledged Python programmer, like you're going to make your career with that, I don't know. Then I agree that C++ is a more beautiful language. But as a beginner, you can begin with anything. You can begin with either. And since C++ is way more difficult, maybe you should start with Python. But I think then the risk is very, very large that you will just completely concentrate on Python, and at some point you become a Python programmer, and then you will never learn C++. Because that then seems like a step back, because difficult and you don't know it and stuff. Maybe you should learn it both at the same time. You can write simple programs in Python and then write them also in C++ at the same time. And at some point you know enough Python, and then you can continue with C++ because it's faster and more allows more low-level stuff. Certain things you can do in Python that you should not do in C++, of course. So then you don't have to write the C++ version of it. I mean, you can do everything in C++, but you shouldn't. If it is, certain programs are just better in Python. Yeah, hi, Aman. I'm mostly thinking about stuff with regular expressions and so very short programs. Some programs if you have to do some matching stuff, then you can write a Python program in relatively few lines, which would take a lot more lines in C++. It seems that C++ is always big. You always have to write a lot of lines. What the hell is this? Empty. Why to move parents 2? My black to move set maximum ply on parents should add to the vector passed as the last argument. Parents out. Parents out is adding parents. So I'm printing found 7 parents, and then we loop. And apparently I never reach this point. And that is because I'm setting parent ply here. No, that's not true. I'm making a copy of the parent ply. Yeah, I don't know. All 7 should have an unknown ply. Because this is not printing unknown 7 times for every time, then I don't understand. It's just a big number. Equals. Maybe it's not initialized. Yeah, parent ply is 0. So it's initialized with 0 instead of int, the maximum value that fits in an int. Parent info ply infos, that's probably where the infos is created, which comes from here, which is black to move, which comes from to move info. No, it's just black to move. Yeah, that's comes from the graph black to move version 2, which is just this black to move here. That is an info type, which is info nodes type. Which is a utils vector of info objects, which are then here created with using the default constructor. And then the default constructor default constructor of info should set made in moves to unknown for the default constructor. I don't even see a default constructor here. Seriously, no constructor at all. So I need a default constructor that set made in moves to something else than 0. The degree type is, that should be initialized, shouldn't it? No, the number of children are unknown. This should be initialized to 0, however. Anyways, this should be initialized to unknown. Classification can use the default constructor, I suppose. Which would set the bits to 0. Well, good enough for me. Following are only valid if this position is legal. Okay, so the current is unlegal, so I don't have to initialize this. I mean, legal requires a bit to be set, and we just set all bits to 0. Yeah, that should be unknown. So this one was missing. Then parent ply is unknown. Core dump. parent.ply is less than or equal max.ply. It thinks that it is made in 255 now, which is not true. So parent.ply equals unknown.ply, or parent.ply is less than or equal max.ply. And then max.ply must be set to max.ply is just really the real thing. Okay. Now I'll test it. I also want to assert if we ever would get over it, thus max.ply itself is limited. Max.ply, if max.ply gets too large, meaning it becomes equal to unknown, that would not be good. Now unknown is the maximum. I can just abuse that. So if this asserts, then this number of ply doesn't fit in a in a ply type, but why is this int then? Peter moves is an int. No, that is version. It's ply type. Unsigned. I might as well make this a ply type, I think. We change max.ply from signed big to unsigned barely fitting. Set made in ply takes an int. Let's make this a ply type as well then. And then just demand that ply is unequal unknown ply. Yep, that should be working. Assertion classification is draw failed. You get to get through a lot of other stuff now. Let's see, from the top we have this. And calling set mate implies 0. This is a mate position. Found 7 parents. That is correct, that it found 7 parents, and we go to the next mate position. And we do that for a lot of stuff. And then something goes wrong in this position. It must have to do with the fact that the black king is now on the edge here. It's totally not a draw, right? So what is it checking? Found 7 parents. But that would be for the rook somewhere here, and then y2 moves, not the draw. You just give mate. It would be a draw if black is to move. Then I mean, I count it as a draw if black can escape. So black moves outside of the board. The board is infinitely large. So if the rook is here and it is black to move, then we just step out of it. But I don't see why. Entering black to move. Set maximum ply on parents. Black to move. Black king 7-0, white king 7-2, white rook 0-0, that's this position. What's this black about? Oh, in this position black is to move. Yep. Keeps being difficult. That move stuff. We want to find parents of this position where black is to move. So we find parents where white is to move, and then we find these 7 rook positions. There is no draw in sight. Set in how many ply this position is made. So apparently I'm trying to set this on the wrong color with black to move, and I should be doing it on where white is to move. And we have to run this in a debugger to find where that happens. parent info. So the question is where the parent info comes from. Comes from infos. Infos is the second argument to black to move set maximum blind parents. Up, I mean. It is black to move. So yeah, again wrong. So I'm passing black to move here. Which is then only used for the parent. So that this nodes type should be the infos for the parent. And it is also an output. I think the plural is enough for just infos. Parent infos out. Parent infos out. So the thing is called from something, and then that something should be, or have an opposite calling here, white to move parents, and therefore we must have a white to move here. But here it must be black to move, so we need both then. Black to move info. No, it is white to move. Okay. So I have a black to move here, and I don't need. Oh, wait a minute. I do need that here. Also need the white to move, which I might already have. White to move. Not really. Well, we have it here. I'm just abbreviating it all the time. Maybe I should just pass, call it again directly in graph 2. Which is just an accessor, so. Imagine trying to write this without all those asserts. Yeah, so if you're watching, add asserts, add loads and loads of asserts. So now it should be printing all positions that are made in one ply. Let's check that. Ply. So yes, in this position the rook moves there and then it is made. Ta-da. Or this made, or this made, or this made, or this made. Or this made. And then the rook one higher. Go here, mate, and so on. Or higher, and so on. Or higher, and so on. Or higher, and till the edge. And one more till the edge. And then you get, with the king one higher. And then flipped vertical, so flipped in this diagonal line here. Starting here, we can give mate there, or the hook moves higher until 8. I think I went too fast, but okay, I will leave it all in the meantime. That looks good. King to one step to the right. Till 8. Next one, and file D till 8. And so on until and then we give just check the corner to sorry, the edge, not the corner. Yeah. This is the last one. Like we can go one higher with the kings. And that is the last one. And it is. Okay, now totally works. Yes, so let's commit this. Gonna remove the debugger window. Entering. It's another one. Seriously? Okay. I have new switches, but it's gonna be a lot of work to put the new switches in my mouse. Or even break the mouse. Quit DS. If and I push it, obviously. Current board cannot be const because generate neighbors is not const. Why is generate neighbors not const? That is a good question. should be constant. Yes, should all of these, well, these do. Okay, I found all the one blind musicians, and that means that this function probably works. So we need a one for the white to move, and then it's finished, right? Let's see. I'm gonna stop though because I'm getting a visitor again in 40 minutes. I still have to get dressed and eat something. So I'll be back later. Have fun with your coding, if you're coding as well.